In this video, we will continue looking at some properties of the Laplace transform. We already know that the Laplace transform of a function is the integral from 0 to infinity of f of t e to the negative st dt. And we already showed that the Laplace transform of a constant function a is 1 over s, and the Laplace transform of an exponential function like e to the at is 1 over s minus a. And something that is easy to check is that if this function, if the Laplace transform of a function f of t is capital F of s, what would be the Laplace transform of, let's say, 7 times f of t? Then when we follow the definition here, the new function is 7 times f of t, then will be the integral from 0 to infinity of 7 times f of t e to the negative st dt. And then this would be like 7 times, and this antiderivative, that this integral that is left is just f of s. Then somehow the Laplace transform of a number times a function is the number times the Laplace transform. It's similar to what happened with the derivative. Then let me write that property. Also, another property, let me write it out. The Laplace transform of any number lambda times f of t is just lambda times the Laplace transform of f of t. Also, if you consider the sum of two functions, f of t plus g of t, then the Laplace transform of the sum of two functions, if you write down the sum of two functions here, you have the distributive property, and it's not difficult to check that you end up with the Laplace transform of f of t plus the Laplace transform of g of t. Then, in that sense, taking Laplace transform is similar to the derivative. The derivative of a sum is the sum of the derivatives, and the Laplace transform of a number times a function is the number times the function. Let's practice some exercises. What happened if we want to compute the Laplace transform of, let's say, 3 plus 2 times e to the 4t? Then this is just the Laplace transform of 3 plus 2 times the Laplace transform of e to the 4t, and this would be 3 over s plus 2 times, and the Laplace transform, we use this formula with a equal 4, it will be 1 over s minus 4. Then this is the Laplace transform of these functions. Sometimes we are interested, we have a function in terms of s, and we want to know the function f of t that produces that function as a Laplace transform. Let's do easy examples of that. Let's suppose that we want to find f of t such that the Laplace transform is 3 over s minus 7. Then we notice that this is 3 times, and this part is 1 over s minus 7. But this part looks exactly like this. And that means that this is just 3 times the Laplace transform of e to the 7t. And this is just the Laplace transform of 3 e to the 7t. Then this is the function that we are looking for. Sometimes we write that 3 e to the 7t is the Laplace transform inverse of 3 over s minus 7. Then the Laplace transform inverse takes a function in terms of s, and it produces a function in terms of t. The Laplace transform takes a function in terms of t, and it produces a function in terms of s. In here, we need to do a lot of rewriting. Let me do another example. Let's suppose that we want to compute the Laplace transform inverse of the function 2 over 4 minus 7 times s. How do we do that? Somehow this function is similar to this function, but let me rewrite it. Then instead of writing it 2 minus 4 minus 7 times s, let's make the s positive. Let's multiply by negative 2, then negative 2 over 7s minus 4. And we notice that here we need to have a 1. Then I'm going to write it as negative 2 over 7 times s minus 4 over 7. And finally, this can be written as negative 2 over 7 over s minus 4 over 7. And finally, I have this like negative 2 over 7 times the Laplace transform of e to the 4 over 7t. And here you can see that the a is 4 over 7, then you can write it like this. And therefore, this is just the Laplace transform of negative 2 over 7 times e to the 4 over 7 times t. Therefore, the Laplace transform inverse of this is negative 2 over 7 e to the 4 over t over 7 times t. Notice that essentially we have done some rewriting. We rewrite so that we adjust into that. Let me do a final example of this Laplace transform inverse. Let's suppose that we want to compute the Laplace transform inverse of the function 4 plus 6s over s squared minus 4. And we notice that this expression 4 plus 6s over s squared minus 4 doesn't look like the right hand side of these two things, right? Doesn't look like this function or that function. But then we need to rewrite it. And what we're going to do is we're going to use partial fractions to rewrite this. And let's see how partial fraction works. We need to have a proper fraction. This is a polynomial of order 1. This is a polynomial of order 2. Then we are okay. And therefore, we need to factor this if possible. In this case, we have 4 plus 6s over s minus 2 times s plus 2. And partial fraction tells us that we can write it as a over s minus 2 plus b over s plus 2. And then to find a and b, we just keep going. We make sure that we have the same denominator, s minus 2, s plus 2. And here we have a times s plus 2 plus b times s minus 2. And then, since these two expressions are the same and they have the same numerator, the denominator must be the same. Then we have 4 plus 6s must be equal to as plus 2a plus bs minus 2b. But then this is a polynomial of order 1, this is a polynomial of order 1, and two polynomials are the same when they have the same coefficients. Let's see, what is the coefficient of s on the left? Coefficient of s on the left. On the left, the coefficient of s is 6. What is the coefficient of s on the right? We have here a and plus b. Then this is it. And what I call the constant coefficient. Constant coefficient is the part that doesn't have an s. Here on the left is 4, and on the right is 2a minus 2b, right? Then we need to solve that system. How do we solve that system? We can multiply this equation by 2 and add. And if I do that, what do I get? I get 12 plus 4, 16. equal to 4a plus 0. That means that a is equal to 4, and then we replace here, if a is equal to 4, b should be equal to 2. Okay, the whole thing is that this expression, erase here, this expression, we can rewrite it like a is 4 and b is 2. A is 4 and b is 2. Right? 4 and 2. Now we see that this one looks like this, and this one looks like this. This one looks like that with a equal 2, and this one looks like that with a equal negative 2. We can see that this is the Laplace transform of 4 times e to the 2t, and this one is the Laplace transform of 2 times e to the negative 2t. And since the Laplace transform of a sum is the sum of the Laplace transform, then we get that this is the Laplace transform of 4 e to the 2t plus 2 e to the negative 2t. Finally, I can say that the Laplace transform inverse of this function is 4 e to the 2t plus 2 e to the negative 2t. Okay, let's stop here with this example here.